Hi folks, welcome back to my channel. In today's tutorial, I will show you how you can create effective and pretty 2D and 3D dot density maps of population for any country of your choice. Alright, so first step is to install and then load the packages that we need. For that purpose, we'll be using the Pacman package. So if you don't have this one already installed, please do install it. For this one, we will be using pload function, which allows us to, first of all, track those packages we don't have, then install them, and then load them into R. The first one that we'll be using is the ArcGIS package, which helps us connect to the ArcGIS database. In this case, we'll be getting the subnational population of Austria, which is our country for today's tutorial, through this package. The second one is the geodata package, which is going to help us get the subnational boundaries, so then we can join the population for specific subnational units with the shapefile of the subnational units. Of course, because we're working here with shapefiles, we will need this asset package, which is the simple features object package. And then finally, to create a dot density map, or actually to resample dots according to the subnational units, we'll be using the dots package. This is not all, because we also want to visualize our results, and we will first of all create a 2D map using ggplot2, and for that we need to load the tidyverse umbrella package. All right, so apart from these things, we will also create some 3D maps, dot density maps, and for the base layer we'll be using here the digital elevation model. The easiest way to get the digital elevation model in R is to use the elevator package. All right, working with digital elevation models means we work with raster files, so we definitely need the Terra package. And finally, we will wrap up with the rayshader package for creating 3D maps. All right, our second step is to connect to the ArcGIS database and fetch the population dataset. Now, over here, what you will find is the link to this REST API, which we'll be using to connect. But if you're curious how actually you can tap into even more datasets, you can check one of the previous tutorials where I demonstrate how to set up ArcGIS package and then use it in R to fetch some of these datasets. So for now, here is the link. And first of all, what we're going to do is we're going to turn this into a string object so we can actually download this data. And then once we actually do that, the next thing is to establish a connection to the database itself. Now, to establish the connection to the database, we'll be using ArcGIS layers from this ArcGIS package. And then there is a function from this one, which is called ArcOpen. So this is going to enable us to connect to this REST API here and then fetch the data. Once we have successfully established the link to this dataset, we can then load it into R. So I'm going to actually assign this new object to this name, admin1 population. And then I'm going to be using from ArcGIS layers another function, which is called ArcSelect. So this function will allow you to fetch the data to which we previously connected. So the first object here is the data itself. Then the second one is what are the fields that you want from this one. So if you actually go to this link here, you will see what is the tabular version of it and what are the actual columns that it has. We'll need 3 columns from it. So the first one is called HACSC and _1. So this is the administrative level 1 name, and we'll be fetching administrative level 1 boundaries. The second one is the ISO2 name or ISO2 codes, which we'll be using to just filter out the provinces for Austria. And then the final one is the population count. So that one is called population. And since this one is a list of columns, we will just close off the list here. Now, what will happen sometimes is that for certain countries, subnational units, you might not have population, it's not available, or it's simply 0. In that case, you won't be able to use this method. But for those countries for which there is the population count, you can definitely use this. You can, of course, always connect to data set, filter out your country, and I will show you how you can filter out, for example, Austria. So how you can do that is using this where attribute, which is like in SQL, simply filters out. So where, and then over here, you need to write a string. So what you can write here is where ISO2 and then equals, and then again you need within this one to put single quotation marks, and then ISO2 code for, in this case, Austria, which is AT. You can also check out some other countries. Now, this is actually going to return you an SF object, but I found upon returning this one that there were some problems with subnational boundaries. So I was not able then to proceed with further steps, which are about, sampling and creating dots based on that sampling with dots package. So what I did here was I decided to actually drop the SF geometry and then turn it into a data set, which in the next step, we will then merge with the corresponding shapefile of Austrian subnational boundaries. And the easiest way to fetch the shapefile of subnational boundaries is to use the geodata package that we used so many previous times. So what we can do here is we can create a new object, calling it country admin1 SF. And then we can call from geodata a function which is called GADM. All right. And then over here, we need to provide for which country we are fetching the data here. So we are fetching for Austria. So you need to provide an ISO3 codes for Austria, that's out. And then because we are interested here in the administrative level 1 boundaries, then for level here, you need to put 1. And finally, for the path, you can simply choose the current working directory so that you can immediately load it. Now, this object is not going to be an SF object. So what you need to do in the next step is to coerce it into an SF object. And to do that, you can simply use st as SF function from the SF package. Once this is done, it is very, very important that in the next step, you turn this object into a multi-polygon. So it can happen that this object will return some of the features which are polygons, some which are not, which are, for example, multi polygons. But you want everything to be a multi-polygon here, so that you can actually merge this one and the data frame together and then calculate the dot density from using the dots package. All right, and then to turn into multi-polygon, it's quite easy. You can just use this stcast and then simply write here in uppercase, so multi-polygon. Once we have both the boundaries and the population data, we can finally merge them. So let us create a new object, which is going to be called country admin1 population. And then using dplyr from tidyverse, we can use left join here. And then on the left side, we will have country admin SF, so basically the boundaries. And then on the right-hand side, we will have admin1 population. And then the join field is going to be the common field, which is the number or the ID for each of the regions. So this is the field that both of them share. Now, before we actually execute this, I would like to turn this newly created SF object into a coordinates reference system that corresponds to the one for Austria. So how do we do this? Well, it's actually quite easy. We just need to go to the epsg.io website. And then over there, we need to just type Austria and then search for Austria. And among the different results, usually it should be the first one that we will choose. And over there, we can simply go to the Proj tab. And on the Proj tab, we simply can click on the copy text and take that coordinate reference system back with us into R. We're back in R, and I'm just going to paste here this coordinate reference system string that I previously copied from the website. And then I'm going to assign it to this CRS object and put double quotation marks around it so that it's also R recognized it as a string. And then what I'm going to do, go back to this chunk that we previously did and simply transform it into this coordinates reference system using st transform from the SF package. And we're ready to calculate the dot density using the dots package. Now, the way it works is you will define what is going to be the value for 1 point. And this is heavily going to depend, of course, on the value of your total population. And of course, if you want to have more or fewer data points. And then you will actually assign the way these points are going to be calculated. But the basic principle is within the boundaries of every subnational units, you will have certain points created based, of course, on the threshold that you chose. And then these points are going to be randomly distributed within the boundaries of your subnational polygon. So let's get to it and see how this actually works in practice. So I'm going to create here an object called population dots. And then from dots package, I will use a function which is used for creating dots using the dot density method, which is called dots underscore points. Within this one, you need to specify several things. The first one, what is the shapefile? So it needs to be a shapefile that we'll be using. So of course, we're going to be creating or using this one that we previously created. So the one for which we have both the national boundaries and the population, and this is of course the SF object. The second one is what is the column for which you want to calculate dot density. So in our case, this one is of course called population. The third one is the mode that you want to use here, and here I simply will use the one that utilizes the SF object because we are here having an SF object, and of course to randomize these points. And the final one is what is the divisor here, or actually for every point, what is going to be your population value. So for Austria, because it has I think around 8 million, I decided to go for 50,000 per dot, which is not going to create that many dots. I don't want it to be very, very crowded. I want the dots to be visible. But if you want actually to see way more dots, you can definitely decrease this number. And if you want to see fewer dots, then you should, of course, increase this number. Again, this is going to heavily depend on the total population of your country of interest, as well as on the population of every subnational unit. In this part of the tutorial, I will show you how you can easily create 2D dot density maps using ggplot2. Let's get started. So let's create an object called P, and let's call ggplot here. And let's add our first layer. So our first layer, using of course GMSF because we're working with SF objects. So our first layer is going to be the population itself. So it is going to be the subnational boundaries. So for this one, what I'm going to do is I'm going to go for a combo of navy blue filling with a bit lighter blue subnational boundaries. Of course, if you don't want the subnational boundaries to be seen here, you want just the country itself, you can simply choose the same color for both, right? And then I'm actually going to make the subnational boundaries a bit thicker here. So I'm going to put the line width at 0.5. Our second layer is, of course, to add the dots that we previously created. And over here, what we need to do is, again, define the data. So the data is the one that we previously created. So it would be the population dots. That's the first one. The second one is the color. Now I chose here a contrasting color to this one. So I chose here yellow. You can of course choose anything else you find good for you. And then here I'm gonna make dots a bit actually smaller. So 0.1. And then the very last two things that you wanna add here, one is of course the coordinate reference system. So if you're using also a customized one like I'm using, so you should then use this coord SF. And then finally, I'm simply gonna use theme void, which is gonna get rid of any excess background around the plot. All right, and then if you wanna display this map, you can simply type here print and then the name of the object, which is P. And then once you execute this, you should be able to see the following 2D dot density map of the Austrian population. All right, in this part, I would like to show you how we can make 3D dot density maps. And over here, I'm going to put into the mix also the topography of the country. So we will need definitely a digital elevation model. The reason why we're doing this is that I also want to see, apart from the population, I also want to see the topography to understand better, how the population is distributed for certain areas. All right, so first things first, let us get the digital elevation model. And for that purpose, we'll be using the elevator package. All right, Elevator has one very convenient function, which is called get elev raster. And over here, we can get the this elev raster for our country admin1 SF. All right. And then over here, you want to choose the resolution. I chose 7. So the lower one you choose, the lower will be the resolution of your digital elevation model. And you actually do, I think, want to choose a bit lower one so that later on with rendering that it goes very, very smooth. Finally, you want to clip the tiles that you will get and the mosaic that you will get. You want to clip it using the locations, which we previously defined here. Locations are simply just the boundaries of Austria. Right, and once you get this, which should be very, very fast, we also want to reproject this digital elevation model using this previously defined, of course, previously defined coordinates reference system. Now, before we do that, I want to actually course this into a Terra Rust object because I like working with Terra. And then we can reproject using Terra project. So we simply can put here CRS. And to do that, we simply need to use a function from rayshader, which is called raster to matrix. So what we will do next is we will use this function and then we will pass here this reprojected digital elevation model. In this part of the tutorial, I will show you how you can render your 3D scene, and we'll need to render 2 scenes. The first one will be rendering the boundaries, and second one will be rendering population count points. Let's start off by rendering, first of all, the boundaries. To do that, what we need to first pass to our code is this digital elevation matrix that we previously created. So this is going to be our height map. Now, after that, what we need to decide is how our height map is going to be colored. Essentially, what we want to do here is we want to have this colorless, so to say. So what I'm just going to do is I'm going to use here white as a palette. And then simply here you can put, any number you want. It's going to be it's not going to determine. And why am I doing this? Because our main layer is going to be the boundaries, and it's going to be also the polygons of the subnational units of Austria, and we are actually going to use then the colors for that. So basically this is going to be the overlay, and the base layer, which is this digital elevation model, is simply going to provide us spikes. All right, so now to add the overlay, we need a function from rayshader which does that. It has the same corresponding name, so add overlay. And because here we are adding overlay, which is a polygon, we need to tell that to a rayshader. So the way to tell that is to choose this generate polygon overlay. So over here, you need to have 2 essentially functions wrapped. Now, within this one, what you need to do then is you need to provide this SF object where we have information on the population. So it would be this country admin1 population. And once you have that, you can then define the palette. I'm actually not going to change much the color of the subnational polygon, so I'm going to go for this navy blue. And then you can also choose, if you wish, the colors of the subnational boundaries. I am going to do that, but I'm going to go for a bit lighter version of blue compared to the ggplot2 code. Then if you decide to go with the subnational boundaries, you can choose here the thickness of the lines. I'm going to go for 5. Again, if you don't want to see the subnational boundaries, you can, for example, set line width to 0, and then they're not going to be visible in the rendered object. The final 2 things are extent. For your extent, you definitely want to include this raster file of the digital elevation model. And then finally, for the height map, you can simply pass here this digital elevation matrix. And before we close up this one, you also need to make one more decision, and that is how transparent this overlay is going to be. Well, I don't want it to be transparent at all. As I said before, I want this color to overlay the elevation itself. So because I don't want this to be transparent, I'm going to choose the value of 1. If you want to make this less transparent, or actually, sorry, more transparent, then you can decrease this value all the way up to 0. 0 means that these colors are not going to be visible, all because the overlay would be completely transparent. Okay, so now that we have added this overlay, we can move to the last part of this chunk, which is plotting or rendering this scene. To render the scene, you can simply use plot 3D function. And then over here, again, you need to define the height map, which is this matrix object. The second thing you need to define is the Z-scale attribute, and the Z-scale attribute here denotes how rugged your elevation is going to be, because remember, this is our height map, this is our base layer. Now, if you choose here the default value, which is 1, you're going to get extremely rugged terrain. You might run into risk that your points, which we will render in the next phase, are not going to be visible at all. Now, to prevent that, and especially that we are having here a mountainous country, Austria is an alpine, so mountainous country, we want Z-scale to be much, much higher. So I'm going to go here for 50, and 50 actually corresponds to the resolution of the digital elevation model raster file. So approximately. So I'm going to go here for 50. And then after that, there are some things that we need to customize. One of them is that I don't want to have this panel also extruded around the map. So I'm just going to choose here that solid equals false. That's the first thing. The second thing, I do want to have shadows. So because I'm going to use, of course, the light here, so shadow equals true. But I can also here define what is going to be the darkness of these shadows. So I don't want shadows to be dark. In fact, I want them to be as light as possible. So I'm going to choose the highest value for that, which is 1. Now, after this, you can also choose some other things which can affect the way your render scene is going to look like. One of them is the size of the window that is going to pop up after running this. So I would like this to be 600 by 600 pixels. You can also choose here what is going to be the degree. So for the degree, you want to use this phi. I'm going to use almost a normal degree, so 89, so that I can further decrease the ruggedness of the terrain. Again, if you want a different angle, you can maybe decrease this one. You can also here choose how much you want to zoom in or out. Zooming in means values that are closer to 0, and zooming out values that are closer to 1. I'm going to go for 0.65, somewhere in the middle. And finally, you can also choose how much your scene is going to be tilted. I'm going to choose 0, which means the map of Austria is not going to be tilted at all. All right, we rendered the scene, and you should be able to see this render scene. The problem with it is that we don't see the entirety of Austria, so we need to a bit readjust it. But for now, what we can see is that indeed we have this navy blue color for the polygons and this light blue colors for the administrative lines. Okay, so readjusting our render camera is fairly easy. We can just go ahead and choose a render camera from rayshader, and we know that the zoom is not so good for us, so we're going to increase the zoom value to, for example, 0.75, and then just run this chunk here. And this looks much better. We can see the entirety of Austria, and also we can see that the colors for the polygons and administrative lines apply equally to the entire map. The second and the final step in the rendering is to add points to a rendered scene. And before we actually jump into the rayshader code, we need to do some pre-steps. And these steps involve, first of all, extracting the coordinates from the population dots. That's fairly easy. We can just use st coordinates from the asset package and then pass here population dots. The second thing we need here is to then extract a longitude and latitude coordinates from this quartz object, which has actually two elements, x element, which is for longitude, and y element, which is for latitude. So we're gonna create here a long, and then within this quartz, simply just extract the x element. And then for the latitude, we're just going to copy here, paste the code, change the name, and also change this element to y. And then the last step is to extract altitudes based on the digital elevation model so that our points do not end up, for example, below the ground level or too much above the ground level. So how do we do that? Well, we can use from Terra a function which is called extract, and which is actually going to just do zonal statistics for us. So the object for which we want to apply this is this reprojected digital elevation model. And the second one is for which we want to apply this for. So we want to do zonal statistics on the population dots, because for each dot we want to find out their find out their altitude. Now over here you need to choose, do you want the average, maximum, maybe minimum value? I found that the minimum value actually works the best. So we can go for the minimum value here of the altitude for everyone. And of course, the last step, but very important here, is we do want to remove any missing values, because we don't want to end up in a situation where, well, the altitude actually has missing values. Then we cannot really show all the points on the map. Now, if you quickly inspect this altitude object, you will see that it has two columns. One is ID, and the other one is the actual elevation value. So what we need to do next is we need to simply select this second column from this data frame. And for selecting that, we can simply use from base R these brackets and then select only the second element. All right, once we have this, we are ready to finally render the points using a render points from rayshader. Over here in this function, you will need several attributes. So one is the latitude coordinates, the second one is the longitude coordinates, the third one is the altitude, which we just defined. And then we also need to define some things that we also defined previously when we were rendering our scene, and that is the extent, for which we will again be using this reprojected digital elevation model raster file. For the height map, we'll be using again the matrix object. And then for the Z scale, what you want to use here is something that is smaller than the Z scale for the scene. So for the digital elevation model, you want something smaller here. And what I actually chose here is something that is 2.5 times smaller. So Z scale 20 compared to the 50 that we previously had. And over here for the size, I'm going to go for the size of 3. Some of the points will be still very big, but don't worry, because we can change this in the render high quality part, which is the last part where we actually render the object itself. All right. And then the final thing here that we can also select is the color of points. So for the color of the points, I'm going to go ahead and again choose the yellow color that we previously used in the previous step where we created the 2D map. Once you run this render points chunk, you should be finally able to see points added to our map. And you can see this a very high cluster of points in the northeastern part of Austria. This is the Vienna subnational unit. So there are many people who live there. That's why we see a lot of dots and a lot of other scattered dots just around the country. The next step is to render this object. All right, and the last step is to render our object. But before we do that, I would like first of all to download a specific environment light we'll be using for our object. And once again, we'll be using the Polyhaven website to fetch that one. And the specific one we're going to go after this is Brown Photo Studio 2, which we also used in one of the previous tutorials. So the link to this one I just pasted here. And what we will need to do next is assign this to a U object and turn this into a string by putting the double quotation marks around it. Once we have that, we can then fetch the base name of this file, which is the HDRI file. So you can use base name function from base R, and then we can simply go ahead and download this file to our working directory. We need to specify here the URL. Then we need to specify the name of this file, which is going to be HDRI file. And the last one is going to be the binary mode for downloading this. Once we download this, we can then go ahead and write the rayshader code for rendering the object. And to render the object using a rayshader, we can use a render high quality function from rayshader. Over here, we need to specify, first of all, the name of the file to which we want to export this. And I can just call this, for example, 3d.density austria.png. That's the first one. Then the second one is whether you want to have a preview as the object renders. So I'm going to turn this one on. Then I'm going to actually turn off the light for the scene. That means that only the object will have the light. And then we come to the part where we need to define the light since we're going to be using it. And because we have a customized light here, then we need to pass this environment underscore light. And then over here, we can simply provide the HDRI file. Of course, only and only if you are working now from your main working directory where you downloaded this file. So that is very, very important. Then after that, we can also choose the intensity of this light. So I'm going to go for one, which is going to be not too dark, not too light. If you increase this one, I think the scene is going to be much lighter. And also if you decrease it, it's going to get darker. And then we can also shift this light as well using this rotate function. So rotate N function. And over here, I'm going to actually rotate it by 90 degrees. So it's going to end up somewhere in southeastern part. So the shadow will be in southeastern part, which means in the northwestern part, we will have the source of this light. Okay, so there are some other things that are more or less you can choose as well. One of them is whether you want the scene to be interactive, whether you want to move the scene as the object renders. So I always turn this one on so that scene does not crash if you actually move it during the rendering process. There are also some other things that you can choose regarding the scene, that is the width and the height. I would go here for example, 4000 by 4000 pixels. That's why I chose this size for the width and for the height. Now we come to a very interesting part, which is deciding how our points are going to look in this scene. And over here, I want to show you something pretty new, and that is how do you add gloss to your points. So to do that, what we can do is, first of all, we can tell rayshader that from array render, which is a dependency for rayshader, we want to take a function which is called glossy. So this is gonna define the glossiness of your point. Now, after you say that you want to use this one, then you need to specify what are the arguments here from this function that you want to choose. And there are actually several things here. So if you hover over this one, if you work in VS Code, of course, you can see here that there are several things that you can choose. You can choose color. So gloss is the level of the surface, gloss of the surface, where it's between 1 completely glossy and 0, which is a rough glossy. So what we're going to do is, first of all, for the color, the default one is white, but I think this is going to make it too light. I'm just going to go for the same color that we use for the point in the rendering scene stage. And then for the gloss itself, I'm going to go for something 0.4, which is kind of a between 0 and 1, so glossy and completely glossy and completely not glossy. And then there is one thing that I also want to add a bit here, and that is the reflectance. So here, if you go for 0, means completely there is no reflectance, and 1, there is completely a mirror. And I'm going to go for 0.1 approximately. You can also play with this one further on. And the last thing I want to customize about the point is how big the point is. So you remember we chose over there when we were rendering the points, the size of 3. So I'm actually going to stick to this size of 3. But if you want, you can also decrease this if you want points to be smaller, or you can increase by putting a higher value. It's, again, totally depends on the data set that you're using, whether your country has more population and also whether its subnational units have higher population. Rendering this object took around 7 to 9 minutes, and after successfully rendering it, I actually got the 3D dot density map of Austria that looks like this. You can see on this map that we kept the navy blue color of the overlay. We now have also these points that are also with a bit of a reflectance. and also with a certain level of glossiness that we added to them. The points are of colors 3D, which makes it also pretty cool. They're also a bit elevated from the base layer, from the elevation layer. And most importantly, what you can see also here, that we have the elevation also as the base layer, which is now extruded, so you can clearly see the mountains and the plains, and also how this affects where the population is distributed. And that's all for today, folks. In today's tutorial, you learned how to create both 2D and 3D density maps in R. If you would like to replicate today's analysis, I prepared a link to the GitHub repo in the description box below, so do check it out. Feel free to clone it, reuse it, modify it as you see fit. Let me know in the comment section down below how it went for you, and I'm also very much looking forward to your own use cases and how you take this tutorial on a journey across the world. If you're new to R and you seek to expand your data visualization and geospatial knowledge in R, I prepared a few cool tutorials for you, so do check them out. See you next time.